Okay, so yesterday we have had an introduction about the embedded system, the components, the block diagrams, the definitions and everything. And then we have moved towards the introduction to the microcontrollers. In the microcontrollers, the microchip PIC microcontrollers, first we will be using for our lab applications for the control systems design. And in that microcontroller, there are the which kind of a memories? There are the program memories, data memories, EPROMs, and thereafter the SFRs, the special function registers are, and the CPU is the connecting element between all of them. Among the SFRs, there are variety of the peripherals are there in the microcontroller, internal peripherals for the control purposes. Like any of a system you are designing, you require the devices like maybe for communication devices, timing devices, the interruption devices, reset devices. If you are using sensors, so you need to read the analog voltages. So there are variety of the devices are present. And once we are implementing the systems, any of an electronic system, all these devices need to be integrated together, whatever their necessities are, and based on which any of a communication or anything happens. So similar of a way, so we have two options. One option is use a processor and attach all these different type of peripherals on your PCB, which is available in a discrete format, and then use them for a design of a system. So this is a one possibility for us. Another possibility is that we have a device available that is in the form of a microcontroller, which is having processor, memory, RAM, peripherals inbuilt in a single chip. And that the size of the chip may vary depending on the usability, depending on the requirements. The size of the chip starts from 8 pin to it may go up to 180 pin, 164 pin, something like this, even more than that. So what is better? Use a single chip or use different of a chips and a processor? As per what is better?
Single chip.
Single chip. So what the benefit we get using a single chip solution is that first thing, we have a one component only. There may be certain of a resistors, capacitors also you have to attach, but in place multiple semiconductors, multiple different ICs, you have just a one chip. And you have a one chip only. So our component count is lower. In electronics, whenever we are designing, just write it or just fit it into your mind that whenever you are designing any of a product throughout your life, you have to keep the component count minimal. The least of the component count means components means what are the electronic components you are using on your circuit. They have to be minimum and minimum, only the necessary categories. And how we can make it minimum? By using these intelligent microcontrollers on our circuitries. The reason being for using the minimal component counts are the first thing that microcontrollers fail randomly or seldomly. Means it is a very rare chance that your microcontroller on the circuit will fail. If in very of extreme conditions of a power failure, or maybe some EMI or EMC or something untowards related to the handling of the PCB has happened, maybe the water has spread or something like this has happened. Only in these cases, the microcontroller fails. Normally, the failure happens of normal discrete ICs or maybe resistors, capacitors of these kind of items. So that's why if we are having the minimal component count in terms of these resistors, capacitors, discrete ICs, there is no chance of a failure of the circuitry is. So your product becomes robust. And that's why the more and more focus is towards the microcontrollers now, so that the product becomes robust. So that's what the first benefit you get, that the even the keeping the cost lower of the product, there is a very less price goes towards the maintenance of it. The manufacturing and maintenance, these are the two separate segments. And always what happens that some of the times the maintenance cost of the product becomes so higher that company goes into losses. So even the manufacturing cost is lower, the maintenance cost should also be lower. It should not be like high. So that's what the first benefit we get out of the minimal component count. The second benefit we get the compactness of the product. So today's generation requirement is that the product should be cheaper, and it should be very smaller into the size also, which can fit into your pocket. You would never want systems which is maybe 5 kg, 7 kg weight. If like maybe any type of a systems you take around you, you want the system should be smaller and cheaper. So that thing can also be possible if the electronics is small for them. So microcontrollers gives you that feature also. Third thing, the design of the manufacturing of the product. So if it is the very large number of components are there on the PCB, so it will take more time for the mounting of them. It will take more price for the mounting of them and the manufacturing processes. So the product cost will become higher. So if the component count is minimum, the product cost will also remain in a budget, and easily it can be mounted and tested and put it into the market. So time to design, time to manufacture, and time to market all becomes lesser if we have the minimal number of components. And that's why the designs are going towards the smartness of using the microcontrollers in the smart electronics domain. So if we are using the microcontrollers, then there are the variety of the companies who are producing the microcontrollers. So we are using the microchip microcontrollers, PIC microcontrollers. Can name few more microcontroller companies? Any other microcontroller companies if you are remembering?
Intel.
Okay. Which microcontroller Intel makes?
Sir, Intel 8051 8 328P,
okay,
and 328 also, which is built in Arduino, sir. And Intel 8051 have in our system also, sir, MPMC.
Okay, so Intel makes 8051 series microcontroller, right?
Yes.
And one more you said me, 8 mega 328P or 8 mega 328. Who makes this microcontroller?
AMD, sir. AMD. TMC, I think.
TMC.
Company.
TMC is a manufacturing house, right, in Taiwan. So they manufacture for almost all of the companies. So it is a big manufacturing house which manufacture the microcontrollers for almost all the big companies. But generally, you will not find their own brands in the market. So TSMC, that is. Okay, so Atmega, earlier it was AVR, right? Atmel was the company who was owning this. Atmel's brand is 8051 is also from Atmel. So Atmel is almost the oldest company in this domain, and that 8051 was there. And AVR, but at 8051 was based on CISC architecture, one-to-one architecture. Still, it is based on the CISC architecture, but the demand of the microcontrollers are more towards the RISC architecture. So Atmel made one more brand that is for AVR, that is based on AVR, where the RISC architecture microcontrollers and the peripherals inside the microcontrollers are being made. But some time back, Atmel got almost bankrupt, and Microchip has taken over Atmel. So now all the Atmel series microcontrollers, 80 series microcontrollers, and this Atmega series microcontrollers, which is from AVR, are now from Microchip, right? In recent 5-7 years, almost many of the companies has been Microchip has taken many of the companies. They have purchased many of the companies in the microcontrollers domain, the FPGA domain, thereafter the normal discrete IC domains, and that's how they have become the top company in the semiconductor now. They are based out in USA, but their support centers are everywhere. Nearest to you, Hyderabad also has one of the support center for Microchip, and this Bangalore is the biggest development center for them. We are the design and training partner. Yeah. Okay, so two microcontrollers we have seen. Two more companies. ST Microelectronics, how many have heard you? Have you
Sir, AMD also have a lot of microcontroller, I think, sir. AMD.
Pardon?
AMD, sir. AMD company also build.
AMD makes processors.
Okay, sir.
STM32, sir.
Yeah, STM32 is a series that is from ST Microelectronics, right? So they are also having a good presence. NXP, have you heard of NXP company? So NXP also makes microcontrollers. You can write the names. Yeah, Texas Instruments, TI microcontrollers. So in many of universities, TI microcontrollers are also in syllabus. Thereafter, this Qualcomm makes processors and the microcontrollers both. Even LG also makes microcontrollers. Samsung also makes microcontrollers, but for their own products specifically. So these companies, these consumer electronics companies, make their own microcontrollers. Then there are few of Chinese brands are also who are making or cloning of the microcontrollers, right? Most of the semiconductor companies who are into the design and development are from US. Their manufacturing are in China or Malaysia, Taiwan, and storages are mostly into the Singapore and Malaysia region. Yeah, we don't have the bigger warehouses like a few companies like Renaissance. One more I forgot. Renaissance has the biggest of a presence in variety of domains like display ICs, thereafter communication ICs. There the Renaissance has a good presence. So they are making the microcontrollers. They have the warehouse in India also. So you can save these names, can explore that what all they are making. And some of the times you can use their microcontrollers also. Maybe some of the times you require a microcontroller, which is you are going to do a project which is based on the displays, maybe for some TV applications, maybe some kind of camera applications you are going to make. That time, maybe you can use the Renaissance microcontrollers. So they are cheaper for the display categories. So what happens? Now you may have a question that if I am learning PIC microcontroller, how can I use it for Renaissance? How can I use it for NXP? So what happens? Once you are developing the program, so it is the C language that we use. So C language is standard for every microcontroller, and the program writing design, and the standards of the C, everything is same for each of the microcontroller. What does change? Their software. Like here, we are using MPLABX IDE for AVR. It may be at Admil Studio, or maybe some other AVR tools you are using, GCC compiler you are using. For STM, they have the Cube IDE. Same way for TI, they have their own IDE. So everyone's IDE is different. The software is different. You have to get an experience on their software. That will be a task of a 1 or 2 day maximum. And the SFRs, the special function registers, like for an example, here the pins are denoted through ports, port A, port B, port C. That's what we are writing. In once you are using for the AVR, like at Mega 328P, so you are writing the programs in Arduino directly. So there you are using the high level languages. But if you are going to address the pins directly of the ATmega 328P, you will have to write it as a P1, P2, P3. So in place of a port, it will be P1, P2, P3. So that the naming differences will be there of the SFRs, and that's also few. Every name does not differ. Like it is a timer 0, so TMR0 will be there again. So that what is the difference in the names and how to operate with their software. That's what extra you need to learn, that you can once you are proficient on one microcontroller and you know that how to operate with one microcontroller, that knowledge you can gather maybe within 5-6 days, and you can start working on other microcontrollers also. Same of a ways, like you are right now learning PIC16F887. Microchip has hundreds of types of microcontrollers. Tomorrow, if you have to work on another microcontroller, the same of a knowledge which you are gathering for PIC16F887 will be applied for the other also, like for PIC16F877A also. So that's what we need to learn is how to use the softwares, how to use the SFRs, how to do the settings of the SFRs for the different purposes. And whenever we are writing the program, so how do we design the logic for the hardware systems? That is the important part. Is if you are proficient in the designing of the logic, setting of the SFRs, you can work with any of a microcontroller, either of a microchip or any company. The design standards, the working patterns, everything are kept standard so that the switching of the programs become easy. Also, there are the cases, what will happen that maybe right now you are designing the program for PIC16F887. Tomorrow, you find that PIC16F8, you are developing a product, and tomorrow you find that PIC16F887 is little costly for me for the pricing of the product. And there is some other microcontroller which is available, which is in a cheaper from Microchip. Maybe PIC16F887 you are getting at 250. There is some other microcontroller you are getting at maybe at a 200 rupees cost, maybe 150 rupees cost. It is possible. So definitely your opinion would be to lower down the cost of your product. So what? But we have developed the software based on PIC16F887. So are we going to change the software again? That is again a question for you, that I have spent so many time, maybe months or years, for writing a software on PIC16F887. And now if I have to change the microcontroller, I will have to rewrite the software again and again. So that may be in your mind, but it does not happen because the C language is same, and the name of the SFRs are also kept same in the microchip. Like if Microchip is making the microcontroller, it keeps the names of your SFRs also same for all of the product, for all of its microcontrollers. So what will happen? There are few of a changes you might need to do in your software for the setting of the SFRs, and the same of a software, the same of the working style of the program, the same of the writing of the program will become usable for the other microcontroller, other Microchip microcontroller also. And maybe the previous time, the first time you have taken years for the designing of the of your code, for changing the same code for the another microcontroller will be task of a day or 2 or 3, and then the testing. So whatever we are writing, it is interchangeable for different microcontrollers. That is the use case I had talked about for the Microchip. Now the same code, if I want to port it for the other microcontroller, like for any other STM microcontroller or maybe for the NXP microcontroller, what will happen? That writing style of your program will remain the same. The C language codes will remain the same. Only we need to change the name of the SFRs. Like you have written some program like your ATmega 328P, that is I think 28-pin microcontroller. Am I right?
Yes, sir.
Yeah. So here the compatible microcontroller in PIC is PIC16F882. We are right now using PIC16F887, which is a 40-pin microcontroller, and the 28-pin version of this series is PIC16F882. So maybe I have developed some program using PIC 16F882, and it is there in the market. It is working properly. Tomorrow I wanted to change the same program workable for Atmega 328P. So what we need to do, we have to develop the program now in AVR Studio. So but are we going to do the same program from scratch? No. We will create a project in the AVR Studio. We will copy this thing from our PIC library, paste it over there. The writing of the program structures will almost remain the same. The necessary changes you may have to do depending on the working style of the Atmega 328P that you will learn through the data sheets. And the name of the SFRs you will have to change. Like if it is the port A is written somewhere, you will have to change the P1. It is possible that here we are setting the outputs to 0 and inputs through 1. The setting might change. So these kind of settings you will have to change, and the program will become functional for the other microcontroller also. So whatever we are doing, that can be ported across the platforms, that can be ported across the microcontrollers, but certain of changes we need to do. It is not like that we have just copied the program from here and we paste it for the others and it will start functioning. Or maybe the hex file after compilation which we have generated for PIC 16F887, the same hex file will not be working for our PIC 16F882 or maybe for Atmega 328P. So for which of the microcontroller we are generating the files, that file will be workable for that microcontroller only, and that is the reason behind it is a firmware. So firmwares are always platform specific, hardware specific. If you are changing the hardware, if you are changing the platform, that firmware become unusable. Just one more example, like if it is a 40-pin IC, yesterday we had taken an example that on pin number 40, 39, 38, and 37, we had connected a switch, and pin number 30, 33, 34, 35, and 36, we had connected a LEDs. And for that, we had done a setting of trace and port yesterday. Remember? Last session? Did we do something like this?
Yes, sir.
Yes, sir.
Yeah. So if we have done and we have set the trace and the port register, and we had connected the LEDs and the switches in our circuitry this way, and tomorrow my mind changes and I have removed those switches and LEDs from those pins and connected it maybe at 28, 29, 30, 31 number pin, something like this, right? So our hardware is changed. And if my hardware is changed, in that case, the same firmware, the setting which we had done earlier, that will become unusable for me. We have to again change the settings. We have to again write the settings for our trace and port and generate a new file which will be fed in the memory of the microcontroller, and then it can be usable again. So that's why whenever we are going to do any of a project, we have to first fix our hardware. What are the components are required on our circuitry, where it will be connected, how we are going to use them as an inputs or outputs. All these things once you fix on your hardware that is presented on a paper, you verify it that it should work, then you go to the program design. So program designing is a third or fourth stage of your project implementations. And then you design your program and then feed it into the memory of the microcontroller, start testing of it. Tomorrow, if you are changing your hardware pattern, hardware design, the firmware needs to be changed. So that's how the platform specification is necessary whenever we are designing a firmware. Like a software which does not limit you, like a Word, maybe a MS Word license you have purchased and you have given it into the 64-bit Windows 8 system. The same MS Word license can be made activated on the Windows 10 or Windows 11 or Windows 7 64-bit systems. Here the platform independence is there. So got this difference? What is this software and firmware difference and how we have to proceed? Any confusion at this point? No? Okay. So today we are
Clear.
clear. Okay, so today we are moving ahead towards the softwares which we are going to use. So for designing the products, projects and in the microchip domain, we are going to use the microchip, that is the MPLABX IDE. So this is the microchip IDE for the development. And we have the MPLABX IDE, MPLABX IPE. For compilers, we have XC compilers, and then we are moving ahead. So MPLABX cloud development tools are also there. So I'll be introducing you to the things. So microchip IDs are available on microchip.com/devtools. This is the website of the microchip is microchip.com and /dev on DevTools page. These IDs are available. So microchip IDs are, there are the three types of the IDs are available. One is MPLABX ID, another is MPLAB Express, and third is the Atmel Studio. So MPLABX ID there, and the types of the microcontrollers which is there with the microchip is, it is AVR microcontrollers from Atmel, PIC microcontrollers, that is the base microcontroller for microchip, DSPs, DSCs, that those are so 16-bit microcontrollers actually. DSPs you must have heard of. So here the DSPIC, DSC they are called. Then ARM controllers you have heard of. So the ARM ports are called in microchip as SAM microcontrollers. So 32-bit microcontrollers with the ARM processor are called the SAM microcontrollers in microchip. And then there are certain of a security chips are also, that is the CEC chips. So you can write the program for all these types of the microcontrollers in MPLABX IDE. Then there is one more IDE called MPLAB Express. So MPLAB Express is a cloud-based IDE. In MPLABX IDE, you have to download the MPLABX IDE, you have to download the compiler, you can install it on your PC, and then you can start working on them. So full-fledged feature is available under MPLABX IDE. Whereas if you don't want to install the IDs, you are in a hurry or there is a no dedicated PC for you, but you want to develop the program. In that case, we can use the cloud-based IDs. So you can create an account on the microchip cloud and you can start accessing the MPLAB Express. The compiler licenses and everything is there. You don't have to install any of a thing and you can start working. But there is a limitation that this cloud-based IDE is only available for PIC and DSP microcontrollers, not for others. So that's what the limitation is. And then third is the Atmel Studio. So once we are working with the Atmel microcontrollers, these are the AVR microcontrollers. In that case, it is the Atmel Studio is there. So AVR microcontrollers and SIME microcontrollers can be programmed in MPLABX IDE also and in Atmel Studio also. So all these three IDs are available. All these IDEs are free. You don't have to license them. You don't have to pay anything for these IDs to use. But once you are using the compilers, there are the compilers for compilation of the program. In that case, if you are using it for the student purposes, student versions, or for non-commercial utilizations, limited license is free. You can start using them. But once you go and start using for any of a commercial operations, like we develop the projects also, and for development of the projects, we require the licenses of the compilers. So in that case, it is a complete commercial operation. in that case, we can't use the free version of the compilers. We have to purchase the licenses, and for each of the microcontroller and for each of the machines. So there are the two types of the licenses are either you can purchase individual license. So on each of the PC, you will have to purchase a separate license and you can activate your licenses. And then there are the network licenses. So you can purchase a network license, you can put that license on the server, and from there, the development team can access those licenses on their PC. So these are the two different types of the licenses are available for the compiler. So for the commercial operations specifically, but as long as you are practicing at your home, developing some projects for your academic purposes, the student edition is free to use, and you can compile with that. Only the compression features and all these are not available, and which you don't require because your code size will be limited. But in industry, once we are developing, there is the very large code size projects we are designing. That time we need the each and every feature of the compiler, and that's where the licensings are required. So MPLABX IDE is the first foremost IDE for the development of these programs, and it is there on the microchip.com/MPLABX. It supports PIC, DSPs, AVR, and SAM devices. Earlier it was there only for the Windows, but now the versions are there on the Linux and Mac OS also. And this is a advanced version, or this is kind of a base of this MPLABX IDE is the NetBeans. So once you will be working with the MPLABX IDE, in the base, the Java NetBeans IDE are running. The earlier versions of the MPLAB were based on the C, but now they are on the Java. So it supports all the compilers, whether it is the XC8, 1632, and AVR and ARM compilers. And there are the lot more third-party compilers like high-tech compilers, thereafter CCS compilers. All these are also being supported by the MPLABX IDE. So MPLABX IDE is Integrated Development Environment. And whenever we are developing any of a program, any of a project we are developing, we require multiple of things. First, we need to write the program. For that, we require an editor. Once we have written the program in the editor, then we require the compilation of it. So compiler and assembler we require. So as a program, it is an editor, then compiler, then assembler, then we require the simulator, then we require the debugger. So these are the different softwares are, and these softwares are required while we are writing any of a program to make it completely workable in terms of the project. So what are the possibilities? Either you arrange all these softwares separately. You take a separate editor, maybe in Notepad you can write. You take a separate compiler, maybe a GCC compiler. Then a separate simulator you can take, a separate debugger you can take, and write the program, but it will become very tedious for you. So that's why IDE is a single software in which you can run all these softwares separately, one by one, seamlessly, because it is a seamless, it is one by one, because once you are editing the program, that time compilation is not required. Once you are compiling the program, that time editing is not required. So they are run one by one through a single shell of the memory. And that's why they are called as the integrated development environment. Whatever the software resources which you require for the development, that is available through a single software, and that is the MPLABX IDE is. It supports variety of the debuggers also. So we require the different of the debuggers while working with the project, so that whatever the source code we are writing in the computer, it should be fed into the memory of the microcontroller, and we should know that how the signals are processing. So for that purpose, if we have to only program, it is the programmer, and if we have to program and check the signals also, means do the debugging of the things also, so that is the debuggers. So there are the different types of the programmers and debuggers are used during the programming and the project. So once your hardware lab starts next week, I'll show you how to use the programmers and the debuggers, and using the programmers and the debuggers, we will be whatever the program we will be writing in the computer, these will be fed into the memory of the microcontroller on the board, and we can see the signals also using the debuggers. So this will be during our labs. So this is how it looks like once the MPLABX IDE opens up. So this is the main window where the programs are written. This is your project window where whatever the project we are creating, it is displayed. This is the features window, like which one microcontroller you are using, which one compiler you are using, everything is written, how much memory that is getting used. Then this tells about the peripherals and everything which we are using with the microcontroller. And this side is the memory view. So like whatever the program we are writing over here, this goes into the memory. So how the memories are getting filled up, so this shows this window. So we will be using the MPLABX and get to know more about it. Then there are certain of plugins are available. Like my IDE is a standard thing, but for an example, you want to use some external softwares like Proteus for the simulation you want to use, or maybe you have developed something in the Arduino and later on you want to edit them in your MPLABX environment. So for that thing, for addition of these additional features or the additional softwares, there are the plugin feature is there, and there are the plugins that we can add. So once we are going deeper and deeper into the design of the products, there are the variety of the features that we need to add, and which is not a standard feature, like Arduino sketch importer. So that is not a standard feature. We can design the program separately into the Arduino, but tomorrow if I want that whatever the program I have designed in the Arduino, that I want to edit into the MPLABX environment, then we need to download a plugin for this Arduino sketch importer, and we can download and attach it with our MPLABX IDE, and we can start working. So that's what the plugin feature that we have. Then we have a MPLAB Express IDE. This is a cloud-based IDE, and it is having the MPLABX compiler also. So you don't have to take any of the license of the compilers or the working of the things. And then the program starts functioning without of the installation of the without the installation of any of softwares or the compilers. Directly you can create the account on the cloud and can start working for it. So that's how this MPLAB Express IDE is. It includes the MPLAB compilers in the pro-optimized feature. It has the MCC, and it supports the few of the programmers like PIC3, PIC4 programmers or Express programmers. And the MPLAB Express IDE allows you that whatever you have programmed, whatever the project you have designed, that will remain stored for 3 days. Earlier it used to be for 30 days, but now the space, more and more users are using it. So now MPLAB Express IDE allows you that whatever the project you have designed in the cloud environment, that will remain stored over there till 3 days. Within this 3 days of a period, whatever the editing that you want to do, you do, and you can download. Like maybe in the 3 days period, you have not been able to complete your project. In that case, also it will not go wasted. You can download, you can export the project and can store it into your PC. Later on, whenever you want to work on that project again, you can again upload it into your cloud environment and can work over there, and then again can download it. So you don't require the installations of the software. You can work in the cloud environment, keep the backup copy of the project in your local PC. Whenever you want to work, you can upload it over there. The second option is, how many of you have used the GitHub? How many of you have GitHub accounts? GitHub accounts have you created any times?
No, sir.
No. None of us? No. Okay. Have you heard? Have you used any time?
Yes, sir.
Yes. For what purposes, Ravi?
Uploading projects.
Uploading projects. So for that purpose, you must have created your account. Okay, you have cloned a project, Manish. Yeah. So actually, GitHub is a repository, that is a source code repository it is. And the projects, there are the free versions and the paid versions of it. So you can use the free version also, and you can create your page. It is actually you should create, because once you will go for the interviews, for the technical rounds, they will ask you for your GitHub accounts, and they will see that what all you have done. So whatever the project you are doing, we will make you learn that how to create the GitHub accounts and during your lab and upload the projects over there. So whatever the projects you are doing, you can upload it into your GitHub account. You can make a page on GitHub for you, and it becomes visible to everyone. Whatever the code you want to make visible, you can keep it private also, some of the parts. And whenever one asks you to give the references that what all the things you have done, you can give the reference of your GitHub account, right? It is same like a LinkedIn accounts you must have created, na? LinkedIn pages.
Yes, sir.
So all of you have LinkedIn pages. For what purposes? Just to show your professional expertise, right? What are how your profession has progressed through, what all you are doing, what are the certificates you have achieved, what are the projects maybe you have worked on. All these things you can show on your LinkedIn account, right? The same of a way, but on the LinkedIn you can't make a page where you can give a description of your projects or can store the source code of your projects. But on a GitHub account, it is a cloud-based, where you can store your source codes. You can give the description of your project, maybe an open source project you can make, like lots of Arduino projects you can see over there. The libraries are stored on the GitHub, and then you can give the references of them. Maybe someone else, maybe your junior or some of your friend, if wants to know that how this code has been implemented and he's in a confused state, or maybe you can help him through your GitHub account also. That is the peer learning approach that we take. And it is good and it is necessary, actually not good, it is necessary also. As a professional, you should have the GitHub accounts. So there is also one more feature in the MPLABX Cloud IDEs, that you can connect your GitHub account directly from the MPLABX account, and whatever the projects you are committing, it will be directly get committed into your GitHub account. So you don't need to store it into your PC also. The projects will remain updated into your GitHub account from the MPLABX. So that's what the benefit we get. And then there is the microchip community. If you are having some confusion, if you are having some issues, you can get the support from the microchip community also. Then it is the IPE. So it was the IDE, Integrated Development Environment, and then we have the IPE, it is Integrated Programming Environment. And MPLAB IPE is there for all the microcontrollers except from CEC, because CEC has a proprietary programming feature. So that's why for CEC IP is not there. But MPLAB IP is there for all the AVR, PIC, DSPs, SAM, all these. And MPLAB IPE is used for the purposes of R&D purposes. Once you are designing the products for the R&D purposes, where you have to program each and every microcontroller one by one, that time it is better to use the IPE. But once we are using the microcontroller for the production environment, like in a factory, if microcontrollers are being programmed, there the software is already designed, and thousands and lakhs, millions of the microcontrollers that needs to be programmed at a very fast of a pace, because the factory is producing the product at a very fast of a pace. thousands and thousands of pieces lot they have. So in that case, it is not possible for a one person to sit with a computer and do the programming one by one of the microcontroller. It will take him years. So that's how what we have. We have a MPPM3 approach, where in the MPLAB PM3 approach, there is a dedicated programmers are there on which the microcontrollers are put in an array, and all of these microcontrollers are programmed at a time, maybe 100 microcontrollers that can get programmed at a time in the PM3 environment. So once we are having the memory devices programming or array programming for the microcontrollers, it is the PM3 environment we are using. If it is the individual microcontroller programming we have to use, so in that case, IPE approach is there. So when MPLAB, once you will install this IDE, the IPE also gets installed simultaneously. It does not require the installation separate. So it supports PIC, DSPIC, AVR, and SAM devices. It runs on Windows, Linux, and Mac. The programming only environment, so it is easy technician use. Thereafter, the configurations for the easy setups are there. And there is one more thing, is the Segar, J-Link programmer. So if there is the two options. For the SAM specifically, if we are using the IPE environment, we can use the direct programming, direct serial programming of the SAM, or otherwise there is a J-Link port is there in the SAM. So 32-bit, once we will be learning, I will let you know about the J-Link, what the J-Link feature is. And there the programmer is from Segar. So if you are using the J-Link programmer approach, J-Link pins for the programming, that time the Segar programmer will be there, and that also is supported by the IPE. Then we have the compilers. So there are the MPLABX compilers. So for 8-bit microcontroller, it is XC8. For 16-bit, it is XC16. And for 32-bit microcontrollers, it is XC32. So all these XC8 compilers are there for all the microcontrollers. So for AVR, it will be XC8. For PIC 8-bit, it is XC16. For PIC 32-bit, it will be the XC32. For DSP, it is XC16 compilers are there. For SAM, it is XC32 compilers are there. And for CEC, 8 and 32, both are there. So 16 is specifically for the DSP series. So that is XC compilers has the compilation feature for all the microcontrollers. The AVR GCC is only for the AVR microcontroller, whereas ARM GCC is only for the SAM microcontroller. The compilers, once you will download, it will remain in a free version. And for 1 month, or if you activate it through your email for 3 months in a free period, it will go in a pro license, the professional license. After of this, it will reduce to the normal licensing. But once you are doing the commercial operations, you may purchase the annual pro licenses. Approximately the pro license of XC8 or XC16 compilers or XC32 compilers, approximately it comes to be 1.5 lakhs for each of the compiler. But that is required once you are into the production environment, once you are into the commercial operations. So once you are having maybe a company, or you are working with a company at that time as a freelancer, you are doing some commercial operations, that time you require the pro licenses. The more the more number of PCs, the more number of pro licenses you will have to purchase. So compilers are there for each device sizes from 8-bit to 32-bit, and they will be working with each of the operating systems, so Windows, Linux, and Mac OS, and they will remain. And you can optimize them also. So free version, that is a 70% optimization, and pro version, you will have a 100% optimization. There is a flexible licensing, so you can take an individual licensing or a network license. So 8-bit supports AVR and PIC devices, and it is working on MPLABX IDE and the Atmel Studio. It is very easy to use. There are the very easy programming approaches is there, and the code performance or the density that you can enhance on based on the optimization levels. XC16 is there for the 16-bit and DSP microcontrollers, and it supports the minimal. It supports the very innovative code coverage. So in a very small lines of the code or in very small memory, you can do lots of tasks using the PIC16 microcontroller, because once we are writing the program for the DSPs, the code size becomes very higher. In that case, XC16s comes our help, and it reduces the code sizes by the compression feature and the increment of the code density. So that is also very important, that whatever you are writing, that should go evenly into the memory of the microcontroller. So that's where the code density enhancement is required. And whatever the program we are writing, that should execute in the real time. So that's why the minimal execution time impact which is required for the XC16 compilers. Then XC32 compiler is there for the PIC32 SAM and CEC devices. Also, now the MPUs are there. So MCUs, right now, whatever we are talking about, the microcontrollers, that is MCUs, microcontroller units. And microcontroller units are there for the control purposes specifically. But nowadays, artificial intelligence is also becoming very popular. And to work with the artificial intelligence, there are two ways. Either you capture the data sets or the raw data through your microcontroller, send all those data on the cloud level. On the cloud level, the processing of that data will happen, and based on which the intelligence will be generated. So this is a one way to deal with the things, but it requires the connectivity, the storage on the cloud, the processing on the cloud, and it becomes very typical, time lagging and costly also. So nowadays what is happening, that microcontrollers with access of a processing nature, that is MPUs called, the microprocessing units. So these MPUs are being made, and in the hardware itself, every of an intelligence is being provided. So whatever, so in the microcontroller itself, the data is captured, the AI processes happen in the hardware itself, and then the intelligence is got generated. So that's what the feature that is getting started through the MPUs, FPGAs, and the microcontrollers with specific of the graphics feature. So that's where these MPUs, so ARM based processors are used now for the MPUs making also. So SAM, so the SAM series which we are talking about, so SAM is having the MCU also and MPU also. MCUs are used normally for the control purpose devices, whereas MPUs are used mostly for the AI and ML purposes. So that is the complete domain is called embedded AI. That's how it has evolved. So SAM resources are actually usable towards the MPU, and if we are doing any of a AI-based projects, that is a hardware AI-based projects, it is better to use the MPU and the FPGA. So industrial IoT, once you will be coming, there we are using the MPUs for the gathering the data and the processing of the machine processes. Apart from this, there are some more software development tools. So MCC, that is Microchip MPLAB code configurator. PIC MCU is there for the MCC. So some of the times, if you don't want to write the code directly, so there are the software tools available in which you can do the settings and a code will be generated automatically. Now that code you have to edit. So that is the MCC feature is there. This is less used in the 8-bit and 16-bit domain. You can write the codes directly. But once we are writing the code in the 32-bit microcontroller, that is either a PIC32 or SAM-based microcontrollers, there we have to use the MPLAB Harmony, because there are the variety of the libraries are there, and it becomes very tedious for us to write the program line by line directly. So that's where the MPLAB Harmony tool is there. In that MPLAB Harmony tool, we can configure the settings of the program, what we want to do, like timer we want to do. So we will do the setting of the timer. We want to use the ADC, we will do the setting of the ADC. And then we can generate the code using the MPLAB Harmony. So MPLAB code configurator and MPLAB Harmony, both is there for the for giving you assistance on the generation of the code automatically, which you can edit later on for the working of your project. If it is a 8-bit and 16-bit microcontroller, it will be the MPLAB code configurator that is used. And if it is a 32-bit microcontroller, it is the MPLAB Harmony is there. So 32-bit PIC microcontroller and 32-bit SAM microcontroller, MPLAB Harmony is there. And if it is the AVR microcontroller and SAM microcontroller, so for that the ATML start is there. So like for an example, tomorrow you are going to plan design a software for lift, for an example, but you have initially no idea much that how to design the software for lift. But you have established that these components are required for designing the software of the lift. So you can go to ATML start and do the settings of the components, and it will generate a test code for you, and based on the components which you have selected, and that test code can be later formatted for actual working of the project. So a kind of assistance that you get through all these configurators. So MPLAB, all these softwares are free. MCC, Start, MPLAB, Harmony, all of these softwares are free. It is a part of the IDE, and configurable software from Microchip experts are there. Some volume is coming. So all these softwares, configurable softwares from Microchip are free. It is peripheral drivers, communication stacks, algorithms, all these things are free. And now MCC and MCHP Harmony both are merged together. So your MCC and Harmony both are merged together. Now they are working under the same configurator, but once you will launch them, you will have to select whether it is for 8-bit or it is for 32-bit. And then there are the Simulink. So maybe tomorrow you want to do some simulations where we require the MATLAB and the Simulink. So MATLAB and Simulink can also be attached with our MPLAB where you can use it. Then there is the Arduino. So Arduino, who has used?
Sir, I have used, sir, Arduino.
Okay, you have used Arduino tools. Anyone else?
Yes, sir.
Okay.
Yes, sir.
Great. Okay, so many of us. So Arduino is what Arduino is actually?
Sir, it is a
Software.
device. Sir, software, sir, hardware.
Okay, so Arduino started as an open source project for the software IDE, right? So Arduino started as an open source project for the software IDs, and it is a free to use. And later on, the company has made the specific development boards based on the Arduino IDs. These are the Arduino boards you are saying. And then other hardware companies have also made their development boards, which is compatible to the Arduino. So like the same MPLABX IDE is the proprietary for Microchip. So, but for Arduino, they have made it open for working with variety of the company's development boards. So that's what the benefit we get with the Arduino is, that we get lots of online tutorials, mentors, sample projects in the Arduino. The free of libraries are available. And even if you don't know very good of a programming, like even if you don't know the complete of a C language or anything, there are the easy to use functions are made, and you can use them for making your projects. But there is a certain of a limitations. If you are developing those things for your project purposes, for the academic, or maybe just for the prototyping purposes, it is easy to make, and you can make it, you don't have to wait for it. But once you start doing the same thing for the industrial implementation purposes, there are a lot other concerns come. First thing related to the code size. Whenever we are doing the project for the industry, the code size should be minimal. So, but once we are doing in the Arduino environment, there are variety of the libraries are included with it, and the code size becomes higher. Second, the libraries which you are using, libraries you are not designing. Libraries are designed by third parties. Anyone else is designing the library who is uploading it on the GitHub, and you are using those libraries, installing into your Arduino IDE and using those libraries. Now, being a user of those libraries, you don't know that what are the security holes in those libraries are. It might be possible that inside of the library, the designer of the library has put some security holes, which is stealing your data or maybe changing your processes, something. In that case, the security certificates of the product you will not be able to get for the industrial implementations. The third issue that comes more and often is related to the functional safety of the products. So whenever we are designing any of a project, we need to ensure the functional safety, that even in the failure cases, the product should not be harmful for the others or for the processes for which it has been designed. That we can ensure only and only once we are writing and once we are having the direct command on the SFRs of the microcontroller. By writing a high-level program, we don't get the direct command on the SFRs, and they may behave erratically. And that's where the functional safety of the product is not ensured. So that's why Arduino is an environment which is good to start with for the prototyping purposes, for starting of the learning purposes. But as you are shifting more and more towards the industrial design, you will have to shift from the Arduino towards the industrial softwares which the companies are using and the industrial microcontrollers. I have brought this idea over here. Arduino microcontrollers, that is Atmega 328P, is actually from Microchip now. That's why Arduino projects are supported by Microchip now. And even if you have developed the projects in the Arduino environment, now you can import them in your MPLABX IDE. So maybe any of a project which you have started as a hobby project and developed it into the Arduino, tomorrow if you want to do the industrial implementation of it, it can be imported into the MPLABX environment. You can restructure the program, reframe the program for the industrial implementations, and can start use them, right? So Arduino also we will be learning, but our motto will remain that how to develop the program in the Arduino and bring them in the MPLABX environment for the industrial implementation purposes. So here Arduino is C++ based. So our libraries and everything you will find it is in a C++ based. So Arduino sketches can be imported into Atmel Studio directly and to the Microchip environment. It converts the C++ project. So Microchip XC compilers, as I'm talking about, it is the C and C++ both languages it supports. And there is one more thing. Microchip has chip kit boards directly from Microchip if we are purchasing. So there are the Arduino boards are there, and then there are the chip kit boards are there. So the chip kit boards can be directly working with the Arduino IDE also. So it lacks the debugging support. It lacks it is not suitable for the professional development. So that's why we will not pursue it more. For initially during our IoT sessions, I'll let you know how to use the Arduino, and then from Arduino how to bring it to the professional development level. That's what our motto will remain. So both the learning is possible. So now it is the time to go for start of the labs. And for that, actually, there are two things. One is the MPLABX IDE. There are the two approaches. One is the MPLABX approach. Another is the cloud approach, the MPLAB Express approach. But to working with any of the things, first your Microchip account. So on your this LMS, I will post the links, but here again I'm showing you that how to move ahead. So here you can see here is the link for this MPLAB Express. So if you want to do the things with the microchip, you should have an account. And if you are having an account with the microchip, you will get the latest of the updates, the 3-month upgrade of your software licenses if you are installing it into your computer, and the other of the updates, other of the things which is happening in the microchip environment, all these updates that you are getting. So you need to create the account here. I will share the link in your in your LMS, and you have to register yourself. Like here, you can see if you don't have an account, so you have to create your account. So it asks you to use your name, email IDs, password, company name, all these things it will ask you. So you can use your college ID, college email IDs over here also. And then you can register for it. Once you will register, so this is called as a My Microchip account or Microchip One account, this is called. So you become eligible for getting direct technical supports, or some of the times once you are developing the projects and that time you require some samples of the microcontrollers also you can take. There are the tools if you purchase later on, so that tool support you can get. And there are the other of notifications or product updates, all these things which are coming, those all things that you can get through the Microchip One account. So this is the URL for it. Now, if I'm using a MPLAB Express ID, so I'm giving you introduction on both. So if we are using on MPLAB Express ID, it looks like this. And once you will create your account, then you will log in to Microchip. And here I had shown you this MPLAB Express. So this is the link for the MPLAB Express. This is the link for MPLAB Express. All these things will be uploaded in your LMS. And once you will open this, you will press on this Get Started Now. If you will remain logged in, so it will directly come to your dashboard. If you are not logged in, it will ask you to log in. And then this is the dashboard for the project. This gets opened. Here already a project is created, but we want to go again. So here the menu is there. So this is a cloud-based IDE I'm displaying you. So here we can go to File, then New Project, and this the options come. So Microchip Embedded, then Standalone Project. This we are creating. We'll press on Next. Here we need to select the microcontroller. So our microcontroller is what? It is PIC 16F887. Then press on Next. Now we need to give a name of the project. So this is our day 3 lab demo. And then we press on Finish. One more thing, if you are working on the cloud ID, then you should have the stable Wi-Fi connection. On mobile data, it will become very tough for you to load the IDs. So it should be the good Wi-Fi connection is required to work on the cloud IDs. So here you can see that the project is created. This is called the project workspace. It is created. And there are the groups for the headers, linker files, source files, important files. Then it is the dashboard. So it is the project name is day 3 MPLAB demo. Our device is PIC 16F887. There is a, right now it is blank. The compiler to chain is XC8. Right now we have written nothing. So our blank memory is blank, and these all are the features. Now, if I have to write a program for an example, so here we will go to source file, or we will go to press the right click button, new file, and we are going maybe for a C source file to write. There are the three types of files. The header file. So once we write the program, there might be sometime we require the headers, so that the header file. Then it is the main file, so where the main function will be there. And then along with the main file, there might be another files also. So that is called as the source file. So we are going to write a main file. Name we need to give. So it is a test day 3. Finish. So you see here, automatically this code has come because we had created a main file. So our first is the include xc.h. So as you have written the C language programs earlier, where you include stdio.h or maybe c.cpp, something like this. Remember? stdio.h, string.h, something.
Yes, sir. stdmac.h.
Exactly.
lib.
Yes. So that is what it means. You are including the definition files from the library. The same way we are working with the microcontroller, and the definition files are here in the xc.h file, right? That's why we need to include them. This is a kind of a pragma. Then the main program part is in the void in the main. So that's why void main, it will not return anything, and void. And then whatever we want to do in this, like I want to do no operation, something. So it is a NOP I have written. Whatever the program will be there, we will be keep writing in this. There is one more thing here. So in the hardware domain, whenever we are writing, every of action which we want to do repeatedly, normally what happens once the program is executed, like for example, you want to blink the LEDs. So one LED turns on, then it gets off, then another LED turns on, then it gets off, and this process keeps continuing. That's what you want. So if we have written the program that here include xc.h, turn on first LED, then some delay, then turn on second LED, then some delay. If we have written just this only, what will happen? That program will start executing from line number 1 up to line number 9, it will go, and then it will stop. Repetition of the program does not happen. But in real-time environment, we need to do certain of our tasks repeatedly. Like here, the turning on and off of the LEDs, both the LEDs are a repetitive action. So that's why the things in the program which we want to do repetitively, that should be put in an infinite loop. And that's where this while one loop is there, which is used for putting the section of the program, which is a continuous, which is repetitive, into an infinite loop. And that's where this while one, right now we are there is nothing we are going to do. So that's why infinite loop, 1 will never become 0. So this loop will always remain true. That's how this and this no operation, NOP is no operation, and it will keep working on. So this is the generic program structure in the MPLABX IDE is. So this MPLABX is there for you once you are working in an environment where you don't want to install the compilers, you don't want to install the IDEs, you want to work with your project, and then you will keep it stored. So here for that, here after writing of the program, I have done the compilation. So this is a build project option is there. And as I have built it, you can see it is written correctly. So the build success message we have got. Yeah. So build success message we have got. And if there is a certain of an issue I have created, so like here I have removed this semicolon. you can see the error is generated. One error generated, and it is showing me where the error is. Error expected semicolon after expression. So C710. So here 7 number is this line where the expectation is off. So syntactical errors, if we are doing, it can let us know that the error has occurred. But if it is a logical error you have created, this will not be told. The logical error you have to rectify on yourself, because that will make your program non-functional. But if there are certain of a syntaxes you are missing, that thing will compiler will let you know. Now, if we have designed this, then we will do the programming in a real-time environment. But right now, like if I have worked on this project and now I want to store it into my PC, for there we have to go to File and Export Project. So here a zip archive is created, and in the name of the day 3 MPLAB demo, and I can store it. So whatever we have written over here, that is there in the zip archive. I can extract it here. It has come, and here the file you can see. The same file has come, include XC.h, void main screen. Okay, so notepad file, are you able to see?
Yes, sir.
Yeah, so the same of the program that has come here, the void main, while one knob, everything. So whatever we have done in the cloud environment, that we can download it to our PC and can start working on them. Tomorrow, if you have done certain of changes in this, like here I have done some changes. I have made one knob more over here, saved it in what. So these are the offline changes we have made. And now tomorrow, so I have to again send it in a WinZip. And I want to just import it again. I'm going to use it again, so I have to import it. We have to choose the file. We will import it. So you can see here the project is imported, and now we can work on it again. So that's how whatever you are working on, you can store it into your computer, and then you can import it into your environment again. So you can work it. So this is the working with the cloud IDE. In our next session, we will in our lab this MPLABX IDE is installed. Compiler is already installed. So if you are working at your home, maybe you can use this Express IDE, and you can download the code. You can export the code in your PC, and later on you can process them in your lab also. So because in the lab we want to use the full feature, there the MPLABX IDE we are using. And tomorrow session, I will be going to let you know first how to use the desktop version, how to use the installed version of the MPLABX IDE in your PC. And then we will move towards the C language that whenever we are writing the program, so we need to write the C language program. So for that, we will be moving towards. For the download of the MPLABX IDE and the XC compiler, I will place the link on the LMS. You can download it from there if you want in your PC. Otherwise, once you are in the lab, so already the softwares are installed in the lab. For tomorrow, our lecture session will be online. But if some of you want to go to lab, do the hands-on with the MPLABX IDE, so madam will remain present. You can go, you can do the hands-on with the MPLABX IDE in the lab. Session will be at 9:30. The lecture will be there also through online mode. And maybe if you want to join from your home, so you can join from your home also. So both the possibilities are there from tomorrow onwards because our software sessions are starting. If you want to join from your home, you can join. You can do the practice at your home. If you want to come to the college tomorrow, you can come, attend the session over there, and then can do the practice in the lab. So both the options are. Is it clear?
Yes, sir.
Okay, so whatever we this video that will get uploaded, the links to download the software, the links to create the account, and the how to use the things, all these things will get uploaded in your LMS in some time. You can access them, revise the things, do the things, and then come prepared next. Right? So have a wonderful day ahead. Any questions if you have, you can ask me here for 5 minutes. You can ask me right now. Otherwise, you can put on your LMS. I'll answer. Any questions for now? Right now, for the student version, these are the license-free compilers. But once you are into the commercial working, all the licenses will be paid. All the compilers will be licensed, paid. As long as you are a student and doing the things on a hobby purpose, there is no license required. Anything more? Okay. So, okay, Samvit, you had a question on the using the LMS. So this is my view. So here, once you will log in into your Edredo account, on the left of the side, you will have the class listed. So like, for example, here it is internship class is there. You will have only one class. I have many because all the classes, those are getting conducted, I'm attached with. So once you will click on them, it will come this is the interface that will come to you, class, home, and everything. Here, this is the feed. So whatever the latest that gets updated, it will come in your feed. If any of the announcements I have to make, I will also put on in the feed here. If you have to write something, or if you have a certain of a question, you can write over here. I will answer over it. So this is your wall actually. The feed is there for the wall. Now to access the course materials, here you will have to go to courses. And our course is Embedded Systems IoT. So I will go to view over there. Now here for our chapter 1, the orientation session. So is listed. I'll press on view and here your video gets there, and you can start playing the videos. So that is there for your orientation session. Now, yesterday we had a chapter 2 on the introduction of the microcontrollers and embedded system. So in the chapter 2, once we will click, there are the resources available. I had uploaded the data sheet. So you will click on the data sheet. You can download into your PC and view the things. The notes are there for the introduction to embedded systems. You can download it into your PC, view the things, and then the video recordings. So that it is here, recording. You can play the recording and have the things, right? So this is how you can use it. Okay, applications of MPLAB. MPLAB is a software. Valagopal, MPLAB is a software for writing the programs for the microchip microcontrollers, like your PIC microcontroller, SAM microcontroller, AVR microcontroller. So application is for designing of the program, compiling of the program, feeding it into the microcontroller. So all the actions which is related for the development of the embedded project, that application is provided by the MPLABX IDE. Any further question? Sambhav, is it clear to you how to use the LMS?
So it is showing no classes are found.
So have you registered for the, you had to select your class also. Once you are registering, that time you had to select the class for which you have been registered. Let me see. Your internship, right? You are not in the class. Your internship now? Shamavi, you are registered for internship or KIP?
Yes, sir.
Internship or KIP? What is your batch? You are in third year or second year?
Third year, sir.
Third year. So you have not registered for the class yet. Your name is not here.
Sir, but I have logged in, sir.
You have logged in, but you have not. Once you have to register again using the same link. You have to register again, and that time you have to give your you have to select the class. Actually, while registering, there is a classes are listed. So you have to list. You have to select the class, and then you will be coming to this. You can take help.
My name is also not there, so.
Right? They all of them, they have registered. You can take help from anyone. Because you have registered right now, but a generic account you have created, but you have to come to this class. That's why you are not able to access the things. Give your college name. For registration, you can give your college name. Okay, so Samvi, just register for the class and then work for it. This is the internship class, internship embedded systems and IoT, for which you have been registered for. So you have to select that.
Okay, sir.
Okay. KIP students, are they, many of you have joined? Rest of you have not received the link or facing any issue in the joining? Only 3 have joined.
Sir, my Gmail was wrong. One letter was extra, so I have sent it again, sir. Sorry for the problem.
Okay. Okay, you can send it on the number again, that is on 9971. And this is the technical support number also for you later. If you have any of the technical issues, you can WhatsApp on this number.
Okay, sir.
Okay, so just keep a note of this. This is our technical support number 9971 192729. This is and if you have any of issues related to your admissions, fees, administrative issues, if it is, so it will be 9654 596573. Just keep a note of these 2 numbers. For any of a technical support on top of the number, for any of administrative support, the below number, can save it. So on both of the number, you can WhatsApp your name and your batch. We will resolve the issue. Yes, Ravi, the microcontrollers and any of a development that you do in the microcontroller domain, that will be done in the MPLAB. Yes, it is there for the microcontrollers.
Sir, nowadays Python is being used, right? So
Yes.
C++ is will be there continuously or because we are going to learn on C++ and
No, once you are in the embedded domain, right? First, you have to learn C, because at the base, the C is running everywhere. Once we are interacting with the hardwares, it starts with the C. Then once we are doing the object modelings and all, then we move towards the C++. And Python is becoming increasingly popular nowadays. Once we are into the IoT and AI related projects, there the Python integrations are there. Cloud integration, if you have to do, so that time you will have to use the Python integrations. Those things can be done in the C language also, but Python becomes little easy to use. That's why people start using the Python, right?
yes, sir. Okay, sir. Thank you.
C++, Python. These 3 are the necessary parts in your embedded profession.
In Arduino, which language is used, sir?
Pardon?
In Arduino, which language is used?
MPLAB?
Arduino, sir. Arduino.
Arduino is based on C++ libraries. Here for microcontrollers, we call it as an embedded C or embedded C++. There is a certain of a differences. I will let you know what are those differences. All of you have learned C na, at your first year or second year?
Yes, sir.
Yes, sir.
Revision, doing the revision is very necessary. I had seen your papers. Because if you don't have a good command over C, writing the projects will become typical. So we are doing extensive session on the C. That's why you should know that what are the basics of the C is required for the programming. there are the two things. First, you will have to develop the logic for it. And for developing the logic, you have to put yourself in place of the machine. Once that logic is developed, then writing the program is very easy. It is just knowing the grammar of it. Right now we are talking English, Hindi, Telugu, any language. So how do we talk so easily? Because we know the grammar of these languages. And that's how we are talking easily. Same way, once you have a command over the grammar of C, it becomes easy. And the beauty is that the grammar of C matches with the grammar of English. The alphabets, the numbers, everything matches with English. Whatever the words you are using in English, the same word you are using in the C language also. It is only a focus that you will have to give towards that, how to arrange those words. So it is not typical. It is little of your attention is required towards how to arrange it as per the grammar of C, and it is there. The more of a focus should be towards development of the logic. And for development of the logic, there is a no book, there is a no guidelines. You will have to work yourself. You will have to put yourself in place of the machine, how you will, or how your brain functions, how you will behave for doing the task. The same way you will ask the machine also to work. Like if I have to add two numbers. So how our brain functions for adding up the two numbers? It stores the numbers in our two locations in our memory. Add those numbers, generate the result, store it into the brain memory, and then speak it out. Same of a way, if I have to do it into a C programming, we will have to take two variables to store those two numbers that will be stored in some memory locations. We will be using our arithmetic and logical units for addition operations. And once the addition operation happens, then the result comes, that is through the processor. The result is stored in some memory location again, and then it is printed. So the process is same as you as a person will do the addition operation. The same way machine will also operate. But here you don't have to be asked the steps one by one, but think of first time when you was learning the addition, first time in your school, someone must have taught you that how to add these two numbers. The same way you will also have to teach your machine that how to add those two numbers. And for that, we write the steps, we write the statements, and that is in the form of the grammar of C language if we are using. So it is not typical, it is just the thinking you will have to give towards that, how to make machine functional for our purposes, how to give commands to the machine so that it will solve our purposes, right? Okay, so thanks to all of you. Have a wonderful day ahead. The session will be updated. You can have a review of it tomorrow. First, we will be having online. Who wants to join from home can join, do the practice at home. But this week only. From next week onwards, all of us have to come to lab, lecture, lab. Everything will be there in the lab itself and on the hardware. This week you have a little of a leisure to do either at home, or from tomorrow onwards you can come to lab also for the practices. Thank you. Any questions still, or shall I close it?
Sir, in our mini project that is related to 805 and microcontroller, sir. So we use
Yes.
Flip software, sir. What is the
Yes.
difference between this MPLAB and Flip, sir?
MPLAB, there is no relation between the MPLAB and the flip-flops. It is MPLAB is the software ID, right? It is separate. You can do the same. What the project that you did in a mini project, as a mini project on 8051?
That was one touch alarm system for women safety.
Okay. You told yesterday, yeah.
Yes.
The same of a program, same of a functions, we can design using the PIC microcontroller, right? but with a very minimal number of components what you have used on 8051. What are the components you have used in 8051? The microcontroller you have used, right?
Yes,
Then
GSM,
what other things?
GSM,
GSM you have used, and
buzzer, LCD.
budget. So these are the external devices. Then for GSM to operate on, you must have attached the current drivers in between so that the pins can come at a level.
Yes.
Do you remember the current driver ICs you have used? Was it functional properly?
No, sir.
So what has happened?
Problem was with code, sir.
Problem was with code. Actually, the current drivers must be there. Then the code is a part. So we will be learning here. But if we are using the PIC microcontroller, you don't have to attach those current drivers, the resistors and semiconductors separately. In the one microcontroller, you have all the features. You will have to just attach the GSM and the buzzer, and it will the program you will have to write, and it can start functioning. Now the program, whatever you will write, that you will write in the MPLAB IDE, not in the admin store.
Okay, sir.
Yeah, there is one more thing that registrations till this week is on. So if any one of your friend who still wants to register for the session, you can ask him. And for that, you can contact to either Shravan sir or Rupa ma'am. She is present over there, and can take the admissions till this week only. Next week onwards, there will be no registration will happen in this batch. So if anyone is still interested, you can update them. Okay, so shall I close now? Yes or no? Still any question? Okay, so I'm closing. Thank you. And just do the revisions. Let's meet again tomorrow on the MPLABX desktop version and the C language. Bye.